NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math video. Today, we're going to work through expanding and simplifying an algebraic expression step by step. Let's look at our example. We have the expression ab minus a all squared times b plus 1 all squared times b squared plus 1 all squared. Let's simplify this expression step by step following a specific algorithm. In our first step, we'll factor out the common term from the first bracket. We can rewrite ab minus as a times b minus 1. Now, let's simplify further by distributing the exponent. We know that when we have a factor raised to a power, it's the same as raising each part to that power. So a to the power of 2 times b minus 1 to the power of 2. Let's take a closer look at the next part of our expression. We have b minus 1 squared times b plus 1 squared. We can use the formula for the difference of squares to simplify this. The product can be rewritten as the square of their product minus the square of their difference. Now, let's simplify the expression inside the square brackets. We know that b minus 1 times b plus 1 equals b squared minus 1, using the difference of squares formula. So our expression becomes a squared times the quantity b squared minus 1 squared times b squared plus 1 squared. Let's continue by looking at the product b squared minus 1 squared times b squared plus 1 squared. Using the same approach as before, this can be written as the square of their product. Again, we'll use the difference of squares formula to simplify the expression inside the square brackets. B squared minus 1 times b squared plus 1 equals b to the power of 4 minus 1. So our expression becomes a squared times the quantity b to the power of 4 minus 1 squared. Now, let's expand the remaining squared term. When we square a binomial, we get the square of the first term plus twice the product of the terms plus the square of the second term. So b to the power of 4 minus 1 squared becomes b to the power of 8 minus 2 times b to the power of 4 plus 1. Finally, let's distribute a squared to each term in the parentheses. Multiplying through, we get a squared b to the power of 8 minus 2 a squared b to the power of 4 plus a squared. So, our final answer is a squared b to the power of 8 minus 2 a squared b to the power of 4 plus a squared. Let's summarize the steps we took to simplify this algebraic expression. Welcome to this math tutorial. Today, we're going to learn about some powerful algebraic multiplication tricks that will help you solve complex-looking multiplication problems in your head. Let's start with our first example. We want to multiply 998 times 1002. For problems like this, we can use a special pattern to make the calculation much easier. Let me introduce you to the difference of squares formula. This states that when we have a minus b times a plus b, it equals a squared minus b squared. Now, let's apply this to our example. First, we rewrite 998 times 1002 as 1000 minus 2 times 1000 plus 2. Next, applying our difference of squares formula, we get 1000 squared minus 2 squared. Now we can easily calculate this. 1000 squared is 1 million and 2 squared is 4. So our result is 1 million minus 4, which gives us 999,996. Now, let's look at our second example. We want to calculate 850 squared minus 750 squared. For this problem, we can use our difference of squares formula in reverse. Remember, a squared minus b squared equals a minus b times a plus b. Let's apply this to our problem. We rewrite 850 squared minus 750 squared as 850 minus 750 times 850 plus 750. Now, let's simplify. 850 minus 750 is 100, and 850 plus 750 is 1600. Multiplying 100 by 1600 gives us 160,000. We want to calculate the product of 497 times 503. At first glance, this might seem like a calculation that requires long multiplication. But let's take a closer look at these numbers. 497 is 3 less than 500, and 503 is 3 more than 500. So we can rewrite this expression as 500 minus 3 times 500 plus 3. Now, this is where we can apply the difference of squares formula. The difference of squares formula states that a squared minus b squared equals a plus b times a minus b, or equivalently, a minus b times a plus b equals a squared minus b squared. Applying this formula to our expression, we get 500 squared minus 3 squared. Now, let's calculate. 500 squared equals 250,000, and 3 squared equals 9. So the result is 250,000 minus 9, which equals 249,991. Let's move on to our second example. Here, we need to simplify the expression square root of 2021 times 2025 plus 4. Let's again look for a pattern. We notice that 2021 is 2 less than 2023, and 2025 is 2 more than 2023. So we can rewrite the expression as the square root of the product of 2023 minus 2 and 2023 plus 2 plus 4. Now we can apply the difference of squares formula inside the square root. Using the formula a minus b times a plus b equals a squared minus b squared, we get the square root of 2023 squared minus 2 squared plus 4. Let's simplify further. 2 squared is 4, so we have the square root of 2023 squared minus 4 plus 4. The minus 4 and plus 4 cancel out, giving us the square root of 2023 squared. Finally, the square root of 2023 squared is simply 2023, since the square root and squaring operations cancel each other out. Let's summarize what we've learned today. We explored 2 powerful mathematical techniques. First, we used the difference of squares formula to quickly multiply numbers that are equidistant from a central value. Second, we applied the same principle to simplify a complex radical expression. Both techniques allowed us to perform calculations that would have been much more time-consuming using standard methods. Remember, recognizing patterns is a key skill in mathematics. Welcome to this math video where we'll learn about the difference of squares formula and how to use it for number divisibility problems. Let's look at an example. We need to prove that the number 199 squared minus 18 squared is divisible by 31. First, let's write the expression 199 squared minus 18 squared. Now, we'll use the difference of squares formula, which states that a squared minus b squared equals a minus b times a plus b. Let's calculate 199 minus 18 and 199 plus 18. Now, let's factor this result further. We notice that 217 equals 7 times 31. Finally, we rearrange the factors to highlight that 31 is a factor of our original expression. Therefore, 199 squared minus 18 squared equals 1,267 times 31, which proves that the original expression is divisible by 31. In this video, we're going to solve an algebraic problem step by step. Let's consider this problem. If x equals 20 and y equals 19, find the value of the expression. Open parenthesis x plus y close parenthesis times open parenthesis x squared plus y squared close parenthesis plus y to the 4th power. Let's start by calculating x minus y. We have x equals 20 and y equals 19. So x minus y equals 20 minus 19, which equals 1. Our goal is to find the value of this expression. Let's rewrite it and see if we can simplify it using the value of x minus y that we just calculated. Now, let's use a clever trick. We know that x minus y equals 1. We can rewrite the first part of our expression using x minus y and x plus y. Let's transform it to open parenthesis x minus y close parenthesis times open parenthesis x plus y close parenthesis times open parenthesis x squared plus y squared close parenthesis plus y to the 4th power. The product of x minus y and x plus y can be simplified using the difference of squares formula. We know that a minus b times a plus b equals a squared minus b squared. So in our case, x minus y times x plus y equals x squared minus y squared. Now, we can apply the difference of squares formula again. The product of x squared minus y squared and x squared plus y squared equals x to the 4th power minus y to the 4th power. Looking at our expression, we now have x to the 4th minus y to the 4th plus y to the 4th. The minus y to the 4th and plus y to the 4th cancel out, leaving us with just x to the 4th power. Now, we can substitute x equals 20 into our simplified expression. X to the fourth power equals 20 to the fourth power. 20 to the fourth power equals 20 times 20 times 20 times 20, which is 160,000. Therefore, if x equals 20 and y equals 19, the value of the expression open parenthesis x plus y close parenthesis times open parenthesis x squared plus y squared close parenthesis plus y to the fourth power equals 160,000. Welcome to this math tutorial. Today, we'll solve a step-by-step radical expression problem following a specific algorithm. Let's start with our example. We have the square root of x plus 2 plus the square root of x minus 4 equals 3. We need to calculate the value of the square root of x plus 2 minus the square root of x minus 4. Let's solve this step by step following our algorithm. First, we'll create a product of the given expression and what we need to find. Now, we can substitute our first equation. We know that the square root of x plus 2 plus the square root of x minus 4 equals 3. Next, we'll simplify the squares of the radicals. The square of the square root of x plus 2 is simply x plus 2. Similarly, the square of the square root of x minus 4 is x minus 4. Now, let's simplify the right side of the equation. We have x plus 2 minus x plus 4, which simplifies to 6. Let's divide both sides of the equation by 3 to isolate our target expression. Therefore, the square root of x plus 2 minus the square root of x minus 4 equals 2. In summary, we've solved this radical expression problem using a step-by-step approach. We used the difference of squares formula, applied substitution from the given equation, simplified the radical expressions, and solved for our target expression. This technique can be applied to similar problems involving radical expressions. Welcome to this mathematics video. Today, we'll solve a step-by-step algebraic expression problem using the given values and following the exact algorithm shown. Let's look at our example. Given that it equals the square root of 2 and b equals the square root of 2 minus 1, we need to find the numerical value of the following expression: the quantity a plus b times the quantity a squared plus b squared times the quantity a to the fourth plus b to the fourth plus b to the eighth. First, let's determine an important relationship. If it equals the square root of 2 and b equals the square root of 2 minus 1, then let's calculate a minus b. A minus b equals the square root of 2 minus the quantity square root of 2 minus 1, which simplifies to the square root of 2 minus the square root of 2 plus 1, which equals 1. Now we'll use the value of a minus b to rewrite our original expression. We can rewrite a plus b times a squared plus b squared times a to the fourth plus b to the fourth plus b to the eighth as the quantity a minus b times the quantity a plus b times the quantity a squared plus b squared times the quantity a to the fourth plus b to the fourth plus b to the eighth. Since we know a minus b equals 1, we can substitute this value. For the next step, we'll use the difference of squares formula to simplify further. The quantity a minus b times the quantity a plus b equals a squared minus b squared. So our expression becomes a squared minus b squared times the quantity a squared plus b squared times the quantity a to the fourth plus b to the fourth plus b to the eighth. We'll continue to use the difference of squares pattern. The quantity a squared minus b squared times the quantity a squared plus b squared equals a to the fourth minus b to the fourth. So our expression becomes a to the fourth minus b to the fourth times the quantity a to the fourth plus b to the fourth plus b to the eighth. Applying the difference of squares pattern one more time, the quantity a to the fourth minus b to the fourth times the quantity a to the fourth plus b to the fourth equals a to the eighth minus b to the eighth. So our expression becomes a to the eighth minus b to the eighth plus b to the eighth. Now we can combine like terms. A to the eighth minus b to the eighth plus b to the eighth simplifies to just a to the eighth. Now we substitute the value of a, which is the square root of 2. A to the eighth equals the square root of 2 to the eighth power. The square root of 2 to the eighth power can be rewritten as the square root of 2 squared to the fourth power, which equals 2 to the fourth power. 2 to the fourth power equals 16. Welcome to this math tutorial. Today, we're going to solve a problem about comparing two expressions to determine which one is larger. Here's our problem. Which of the following numbers is larger? We have the square root of 5 plus the square root of 13 and the square root of 34. Let's solve this step by step following a clear algorithm. First, we'll define x equal to the square root of 5 plus the square root of 13. Next, we'll square both sides of this equation to eliminate the square roots. This gives us x squared equals the square of the square root of 5 plus the square root of 13. Now, we'll expand this expression using the square of a sum formula. We get x squared equals 5 plus 2 times the square root of 5 times the square root of 13 plus 13. Let's simplify this expression. 5 plus 13 equals 18, and 2 times the square root of 5 times 13 equals 2 times the square root of 65. Now, let's define y as the square root of 34. Similarly, we'll square y to get y squared equals 34. Now, to compare x squared and y squared, we need to first look at the term with the square root. Let's compare the square root of 65 with the square root of 64. Since 65 is greater than 64, the square root of 65 is greater than the square root of 64, which equals 8. Therefore, 2 times the square root of 65 is greater than 2 times 8, which equals 16. Now we can compare x squared and y squared. X squared equals 18 plus 2 times the square root of 65, which is greater than 18 plus 16, which equals 34, which is y squared. Since x squared is greater than y squared, we can say that x squared minus y squared is greater than 0. We can factor this as x plus y times x minus y is greater than 0. For a product to be positive, either both factors are positive or both are negative. Since x and y are both positive, they're square roots. X plus y is definitely positive. So for the product to be positive, x minus y must also be positive, which means x is greater than y. Therefore, x is greater than y, which means the square root of 5 plus the square root of 13 is greater than the square root of 34. So our final answer is that the square root of 5 plus the square root of 13 is the larger expression. Let's summarize the key steps we used to solve this problem. First, we defined x and y as our expressions. Second, we squared both expressions to eliminate the square roots. Third, we compared x squared with y squared. Finally, we concluded that x is greater than y. This approach is useful for comparing expressions involving square roots. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.